In this video, I am going to explain Trellis, structure of the convolutional encoder. Generally, Trellis structure is a graphical approach used to encode the given message sequence. Trellis structure is a graphical approach used to encode the given message sequence. Like code tree. Second point here is all of you must know the code tree analysis. Before explain the concept of that trail structure, next one is code tree. Code tree is also a graphical approach used to encode the given message sequence. With the help of that code tree, how to design trail structure. Now we will see here the number of outputs n is equal to 2 means two outputs x1 and x2. M is equal to 2. That m is equal to 2 means the present state of the convolutional encoder. A, B, C, D, 4 states. Start here. Start upward direction and downward direction. M is the message sequence. M is equal to 0 upward direction. M is equal to 1 downward direction. Here initial state, let it be A, goes to 2 states, A to A and A to B. This is the current state. This is next state, current state, next state. Here A to A to B. Here B to C and B to D. Again A to A to B, B to C and B to D, C to A, C to B, D to C and D to D. This is the observe this code tree. Here outputs are indicated on the every branch of that code tree. Two outputs x1, x2. Here x1, x2. Here x1, x2 here and x2. X1, x2. Here m is equal to 2 represents the state of the convolutional encoder. M is equal to 2 means 4 possible states are there, A, B, C, D. These states are represented in this diagram, code tree diagram. Transitions are also indicated A to A to B, present state, next state, with output is y, x1, x2. After 3 levels at T1 time, here T1, here T2 and T3. Next one, this one is A to A to B, X1, X2, X1, X2. Here B to C, B to D, X1, X2. Here C to A, C to B. Here D to C and D to D. Here A to A and A to B, X1, X2, X1, X2, and B to C and B to D. C to A and C to B, next to X1, X2. Here D to C and D to D. After 3 intervals, T1, T2, T3, the structure is repeated. This is the structure repeated after 3 intervals. A, B, C, D, A, B, C, D, A, B, C, D. The lowercase A, B, C, D, A, B, C, D. After 3 intervals, the structure is repeated. Next one is code trellis. The code tree has, the important point here is the code tree has three repetitive structure after 3 levels. Trellis is the compact form of the code. Important point here is trellis. Trellis is the compact form of the code. And also trellis is the reducing structure of the code tree. Reducing structure. The structure is repeated. The structure is repeated. Observe this repeated structure. A is the current state. Here A is the next state. A is the current state. B is the next state. X1 and X2 are the outputs of the convolutional encoder shown on the branch of the code tree, branches of the code tree. B is the current state and C is the next state. B is the current state, D is the next state. C is the current state, A is the next state, and C is the current state, B is the next state. D is the current state, C is the next state, D is the current state, and D is the next state. By using this analysis, you have to construct code trellis. next heading, code Trellis. Code Trellis. It is a more compact graphical representation. It is a more compact graphical representation, which is popularly known as portraits. With the help of these transitions here, A to A to B, next to A is the current state. Here A goes to again A is the next state. B, A is the current state, goes to B state. Next here B to C and B to D, C to A and C to B. Here X1, X2 are the outputs of the convolutional encoder. C to A and C to B. And D, here D, X1, X2, X1, X2. Consider after 3 levels, after 3 levels means T1, comma T2 and T3. The code tree has a repetitive structure shown in this is the repetitive structure shown in figure. With the help of that repetitive structure, we have to construct the code trellis. Code trellis is also a graphical representation of the state transitions. With the help of these signal growers, these are the signal flow graphs, how to construct the code trellis. Four states. This is the current state, and the next state, current state, and next state. Here the node on the left side denotes the 4 possible current states. 4 possible current states are A, B, C, and D. And the nodes on the right side are resulting the next state is the A, B, C, D. By using that signal flow graph, with the help of this signal flow graph, here A to A to B, A to A to B. Here A to A. Here A to A. Solid line represents the input bit M is equal to 0. And A to B. Dashed line represents the, here B is there. Here B. X1, X2, X1, X2. This is the upward direction. Upward path means the input message bit M is equal to 0. Downward path means input message bit M is equal to 1. Next, B to C and B to D. Here, B to C. Solid line when M is equal to 0. Output is X1, X2. B to D. X1, X2. B to C and B to D. Next one, C to A and C to B. C2A. This is the C2A. The output is X1, X2, and C2B, X1, X2. Finally, D2C and D2D. D2C, X1, X2, output bit is 0, and D2D, X1, X2. This is the output. This is the code Trellis structure, which is very, very useful to construct the Trellis structure. It is very useful to construct the Trellis structure. Next one, code Trellis is the major representation which is used in Trellis structure for encoding the given message sequence of the convolutional encoder. This is the code Trellis. Code Trellis is the major representation is used in Trellis structure. Is used in Trellis structure for encoding the given message sequence. Message sequence of the convolutional encoder. Consider this code tree. After 3 levels, T1, T2, and T3 levels of that code tree, the code tree structure is repetitive in nature, shown in figures. Here representation shown in figure. This is the A is the present state, and the present state and next states and with outputs transitions are also shown in this figure. With the help of this repetitive structure, we have to construct code Trellis. This is the diagram. The code Trellis also play an important role for design, constructing the Trellis structure. Code Trellis is the major representation used in Trellis structure for encoding the given message sequence of the convolutional encoder. The Trellis structure shows every possible sequence of state transition of the state diagram. The Trellis structure shows every possible sequence of state transition of the state diagram. State transition means this is the one of the sequence from A to A and A to B. A is the current state. Next state is also A. With output is X1, 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 X2. Whenever input bit M is equal to 0, this is A is the current state and goes to next state is B. With output is X1 and X2. Input bit is M is equal to 1, like that. State transitions are represented in code Trellis structure. This is also called as a state diagram. This diagram, these transitions are very, very useful to construct the Trellis structure. Next one, algorithm. Algorithm points related to Trellis structure or diagram. Trellis structure or diagram. First important point here is horizontal axis in the Trellis diagram represents the discrete time steps. First point here is horizontal axis in Trellis diagram or structure represents the discrete time steps. Second important point here is vertical axis in Trellis diagram represents all possible states of the encoder. The Trellis, third important algorithm point is the Trellis contains L plus K levels. The Trellis structure contains L plus K levels where L is the constraint length of the convolutional encoder. K is the capital K. Capital K is the length of the incoming message sequence. Incoming message sequence. Okay. The Trellis structure generally, the Trellis structure contains L plus K levels, different levels, where L is the constraint length of the convolutional encoder, K is the length of the incoming message sequence. The levels of the Trellis are labeled as I is equal to 0, 1, 2, and so on. L plus K minus 1. Plus K minus 1. These are the labels. Fifth important point here is the first L-1 levels corresponding to the corresponding to the encoder departure from the initial state. And the last L-1 levels, correspond to the encoder, return to the initial state. That means original state. Sixth one is important point is in the central portion, the central portion of the trellis for which the level L lies in the range L-1 less than or equal to I less than or equal to K. In the central portion of the trellis for which the levels lies in the range L-1 less than or equal to I less than or equal to K. In this region, the trellis in this region the trellis structure as periodic in nature. Periodic in nature. These are some important points related to trellis structure. Generally, the trellis structure will have L plus K levels, where L is called as a constraint length of the convolutional encoder. K is the length of the incoming message sequence. Here, horizontal axis in trellis diagram represents the discrete time steps. Vertical axis in trellis diagram represents all possible states of the encoder. The first L-1 levels corresponding to the encoder departure from the initial state, and the last L-1 levels corresponding to the encoder return to the initial state. Again return to the initial state. The central portion, in the central portion of the trellis for which the levels L lies in the range L minus 1 less than or equal to I less than or equal to K. In this region, the trellis structure has periodic in nature. Next one. The for last L minus 1 levels are for returning to the initial state, returning that means coming back to the original state, coming back to the original state. At that instant, we consider the input message bits are zeros. Very, very important points. There is some important points related to data structure construction. Suppose L is the let L is equal to 3. Constraint length of the convolutional encoder is 3. K is the message length. Incoming message length is 5 bits are there. Suppose, therefore, the Trellis structure has L plus K levels. L plus K levels means 3 plus 5, 8 levels. Labeled as, the levels are labeled as 0, L is equal to 0, 1, 2 up to L plus K minus 1. That is equal to 0, 1, 2, L plus K, 8 minus 1, that is 7. 7 levels are there. The levels are represented as 0, 1, 2, 3, 4, 5, 6, 7. These are the levels of the structure. One more important point here is indicated in this algorithm is the first L minus 1 levels are covered the first L minus levels are for departure of the encoder from the initial state. L means constraint length. L minus 1. L minus 1 means 3 minus 1, that is equal to 2. 2 means small l is equal to 0, 1, 2. The first L minus 1 levels are for departure of the encoder from the initial state. The first L minus 1 levels corresponding to the encoder departure from the initial state. That means from L value is 0, 1, 2. In between, the L value lies in the range. That means L minus 1 less than or equal to small l less than or equal to K, where K is equal to 5. L minus 1 means 3 minus 1, 2 less than or equal to L less than or equal to K is equal to 5. In this region, this is the central from 2 to 5, because L greater than or equal to 2, greater than or equal to 2, less than or equal to 5, greater than or equal to 2, and less than or equal to 5. This is the central portion of this trellis. This is the central position of the portion or position of the trellis exhibits a fixed periodic structure. Fixed periodic structure, center portion. Fixed periodic portion. In this region, the structure, trellis structure covers all the states. In this region, the trellis structure covers all the states of the convolutional encoder. Very, very important point. Okay, last, these are the two L minus 1, that means 3 minus 1, that is equal to 2. The last two levels, that means L is equal to 6, 7. That means the last L minus 1 level corresponds to the encoder return to the original state. Return to the original state of the convolutional encoder. When the input to the convolutional encoder are zeros. In this algorithm, the trellis structure has L plus K levels, where L is called as the constraint length of the convolutional encoder, K is called as the input message sequence length. The levels of the trellis structure are represented by small l. Range is 0, 1, 2 up to L plus K minus 1. The first L minus 1 levels corresponding to the encoder departure from the initial state, and the last L minus 1 levels corresponding to the encoder return to the initial state. That means come back to the original state. In the central portion of the trellis, for which the levels L lie in the range L minus 1 less than or equal to I less than or equal to K. In this region, the trellis structure is periodic in nature. That means the trellis structure covers all the states of the convolutional encoder. For last L minus 1 levels are for returning to the initial state, coming back to the original state. At that instant, we consider the input message bits are zeros. These are the padding bits. Again, come back the convolutional encoder, come back to the original state. These are some important points related to trellis structure. Now I am going to explain Trellis structure construction with the help of an example. For the convolutional encoder shown in the below, using Trellis structure, graphical approach, encode the given message sequence m is equal to 10011. This is the convolutional encoder diagram. M1, M2, first modulo 2 adder here. M is connected to here. M2 is connected to here. M1 is connected to here. This one is X1. 1. Here, second modulo 2 adder. M is connected. The M2 is connected. The second one. This one is X2. This is the X. X is the output of the convolutional encoder. Here, two outputs are there. Here, a message sequence. One is input to the convolutional encoder. The given message sequence is 10011. Here, M represents the current message bit position. M1 and M2 represents the previous two successive bits representation. Here, capital M is equal to 2. This capital M is equal to 2 means represents the state of the convolutional encoder. M1 and M2 bits are used to represent the state of the convolutional encoder. From the solution, from this diagram, X1 is equal to M exclusive or with M1 exclusive or with M2. M exclusive or with M1 exclusive or with M2. The X2 is equal to M exclusive or with M2. These are the two outputs of the convolutional encoder. First, we have to draw the code structure and then analyze the code Trellis structure. First of all, we have to draw the code tree. First of all, we have to frame the state transition table. Input message. M. Input message sequence. M. Present state. M1 and M2. Next state. M1, M2. outputs x1, x2. Here in this diagram, here M1 and M2 are the two previous two successive bits. Therefore, M is equal to 2, capital M is equal to 2, represents the state of the convolutional encoder. Here X1 is equal to M exclusive with M1 exclusive with M2, X2 is equal to M exclusive with M2. Here capital M is equal to 2 means 4 possible states 0, 0, 0, 1, 1, 0, 1. Consider this one. Present state is 0, 0 here. Two possibilities of M are either 0 or 1 with present state 0. That means let it be A. Here next state means 0, M bit is 0 is shifted to M1. M1 bit is 0 is shifted to M2. That means 0, 0. X1 is equal to M exclusive with M1 exclusive with M2. That means 0. X2 is equal to M exclusive with M2. That is 0. Here M bit is 1 is shifted to M1 bit. M1 bit is 0 is shifted to M2. That means 1, 0. This is the next state is A. This one 1, 0 is B. Here 1, 0 is B, indicated like that. Outputs are M exclusive with M1 exclusive with M2 means 1 exclusive with 0 is 1, 1 exclusive with 0 is 1. Here 1 exclusive with 0. That means X2 is equal to M exclusive with M2. That means 1, 1. This is the state transition completed. That means you are in state A, input bit is 0, goes to next state. That means current state to next state. Next state is also A with output bits are 0, 0. You are in state A, input bit is 1, goes to next state, that is B state, with output is 1, 1. That is a state transitions. Next, consider present state is in B state, 1, 0. Here 1, 0, that is the B state. Two possibilities of M are 0 and 1. Here 0 is the M bit, is shifted to M1. 1 is the M1 bit, shifted to M2. That means 0, 1. Here 1 is the M bit, shifted to M1. Here M1 is 1 bit, shifted to M2. It is 1. Here the shifting operation representation is like that. This one is C, this one is D. Here perform 0 exclusive with 1 exclusive with 0. That means 1. 0 exclusive with 0 is 0. Here 1 exclusive with 1, 0, 0 exclusive with 0. 1 exclusive with 0 is 1. Here consider next one is C. C means here 0, 1, 0, 1 state. Here two possibilities are M are 0, 1 and transitions are like that. Here 0 is shifted to 0. Here 0 is shifted to 0. That means A. Here 1 is shifted to 0. 0 is shifted to 1. That means 1, 0. That is B. 0 exclusive with 0 is 0. 0 exclusive with 1 is 1. Here 0 exclusive with 1 is 1. Here 1 exclusive with 0 is 1. 1 exclusive with 1 is 0. 1 exclusive with 1, that means 0. Last one is D state 1 1 1 1. Here D, two possible values of M are 0 1, like that. 0 of M bit is shifted to 1, M1. M1 bit is 1, shifted to M2, that means 1, 0 1. 0 1 is C. Here 1 is 1, M value is 1, shifted to M1 place. M1 value is 1, shifted to M2 place. It's D. The outputs are 0 XOR with 1 is 1, 1 XOR with 1 is 0, 0 XOR with 1 is 1, 1 XOR with 1, 0, 0 XOR with 1 is 1, 1 XOR with 1, 0. These are the, by using this x1 and x2, that means M XOR with M1 XOR with M2, x2 is equal to M XOR with M2. Calculate these values, x1 and x2 values. State, this is the state transition table. That means present state is shifted to next state with the outputs, and with input bit is either 0 or 1. The representations are shown in the state transition table. By using this signal flow graphs, construct the here signal flow graphs. Here we use A to A. Solid line represents input bit is 0. A to B, A to A to B. With the state transition table, A to A means with output is 0 0. A to B means with output is 1 1. Next one, B to C and B to D. The output is 1 0 0 1. C to A, C to B, C to A and C to B. That means 1 1 0 0. D to C and D to D. The output is 0 1 1. By using these signal flow graphs, I have to analyze draw the code. This one is the start. Here M is equal to 0 upward direction, M is equal to 1 downward direction. Here initial state is A to A. Starting state is A to A. With output is 0 0, and A to B. Here A to B with output is 1 1. Vertical line represents the state of the convolutional encoder or state of the tree. Horizontal line represents the branch of the tree. Outputs are indicated on the branch of the tree. Here again. A to A to B. Here A to A to B. Outputs are indicated 0 0 1 1. Here again A to A to A to B with outputs are 0 0 1 1. Here B to C and B to D. B to C, B to D in the outputs are 1 0 0 1. Here again A to A to B 0 0 1 1. Here B to C, B to D 1 0 0 1. Here C to A, C to A, C to B. Consider this one. The output is 1 1 0 0 and D to C. D to C is 0 1 and D to D is 1 0. This is the A B C D, A B C D. After 3 intervals, that means consider upper portion, upper direction. This is the T1, T2, T3. After 3 intervals, time intervals, the structure is repeated. This one is the repeated structure. This is the repeated structure. Repeated code tree structure. Code tree. After 3 successive intervals, repetition is there. Repeated code tree or repetition of the code. A, B, C, D, A, B, C. And similarly, in the lower portion, that means downward direction. In similar way, downward direction. This one is B. With output is 1 1. Here B to C and B to D. B to C is 1 0. B to D is 0 1. And C to A, C to A and C to B. C to A 1 1. C to B is 0 0. D here is from the D to C and D to D. With output is 0 1 and 1 0. Here A to A, A to A, A to B. 0 0 1 1. B to C and B to D. B to C is 1 0. B to D is 0 1. C to A, C to B 1 1 0 0. D to C and D to D 0 1 1 0. Again, consider this one lower portion. the structure is the repetition of the code tree. Here state transitions are takes place. Let A is the current state. Here goes to A, that means here A is the next state. Here A is the current state, B is the next state with outputs are 0, 0, 1, 1. Here the code tree has the repetitive structure after 3 levels. After 3 levels means T1, T1, T2 and T3 levels. Consider all these levels. The code tree has repetitive structure. Trellis is the compact form of the code. Trellis is the here. Trellis is the compact form of the code. And Trellis is the reduction structure of the code. Reduction structure of the code. Consider this repetition. That means A to A, A to B, B to C, and B to D, C to A, C to B, and D to C and D to D. With the help of these transitions, we have to construct code trellis. This is very, very important. With the help of that code trellis, we have to construct trellis structure, code trellis. Here, this is also graphical representation. Current state, here next state, here output is indicated on the branches here. From that last after 3 successive intervals, the code tree has a repetitive structure. Consider these are the current states A, B, C, D. These are the next states A, B, C, D, A, B, C, D. This is the current state is here is A, B, C, one is B state, one is C state, D state. And the next states are also A, B, C, D. Consider this repeat structure A to A. A is the present state and goes to next state is A with output is 0, 0. A is the current state and goes to the next state B with output is 1, 1. Here M value is downward direction, M value is 1, upward direction, M value is 0. Solid line represents M value is 0, goes to A with output is 0, 0. Dash line represents M value is 1 with output is 1. Next, consider B to C and B to D with M value is 1 upward direction, M value solid line represents M is equal to 0, dash line represents M is equal to 1. B is the current state, C is the next state with output is 1, 0. B is the current state, D is the next state with output is 0, 1. Here B is the current state, C is the next state. Here output is 1, 0. B is the current state, D is the next state with output is 0, 1. The output is 0, 1. Consider C state. Here C is the current state, C to A and C to B 1, 1, 0, 0. C to A, C to A, solid line, but that means M is equal to 0. Here 1, 1, C to A and C to B. C to A and C to B 1, 1 means here 1, 1. C to A 1, 1, C to B is 0, 0. C to B is 0. D is the current state, goes to next state is C when input bit is 0. C state, that means 0, 1. D to D 1, 0. Here D to C 0, 1. D to D is 1, 0. D to C is 0, 1. D to D is 1, 0. By using this code is try this graphical structure. I have to draw the trail structure. After that, I have to encode the given message. Now, trail structure. According to algorithm, this one is the signal flow graphs are very, very important. A to A to B, input bit is 0, input bit is 1, 0, 0, 1, 1. B to C and B to D. B to C with the output is 1, 0 and 0, 1. C to A and C to B 1, 1, 0, 0. And D to C, and D to D 0, 1, 1, 0. By using these signal flow graphs, construct the trail structure. First important point here is that the Trellis horizontal axis represents the horizontal axis in Trellis diagram represents the discrete time steps. Here important point, horizontal axis in Trellis structure or diagram represents the discrete timestamps. First point, first algorithm point. Vertical axis in Trellis diagram. Vertical axis in Trellis diagram represents all possible states of the encoder. Okay. Third point, important point here is Trellis structure has L plus K levels, where L is the constraint length of the convolutional encoder. Constraint length of the convolutional encoder. And K is the length of the message sequence. Here, constraint length L is equal to M plus 1. In the above example, M is equal to 2 previous successive bits. That means M1 and M2. That means M is equal to 2. 2 plus 1, that is 3. Given message sequence is 1, 0, 0, 1, 1. 1, 2, 3, 4, 5. Therefore, K value is 5. K value is 5. Therefore, the Trellis structure has a L plus K levels. L plus K levels means L plus K. That means 3 plus 5, 8 levels. These levels are labeled as L is equal to 0, 1, 2, up to L plus K minus 1. That means 0, 1 to L plus K means 8 minus 1, that means 7. Therefore, L values are 0, 1, 2, 3, 4, 5, 6, and 7. L plus K level. Next one, the first L minus 1 level corresponding to the encoder. Fourth point is the first L minus 1 levels correspond to the encoder. Departure from the initial state. That is A. First L minus 1 levels means L minus 1, that means L is equal to constraint length 3 minus 1, that is equal to level 2 level. That means levels are 0, 1, 0, 1, 2. Departure from the initial state. Next, fifth one is L minus 1 less than or equal to L less than or equal to K. L minus 1, 3 minus 1, 2 less than or equal to L less than or equal to K is equal to 5. In between these levels, from 2 to 5, the Trellis structure is the Trellis structure is periodic in nature. And covers and covers all the states of the convolutional encoder. Sixth point here is last L-1 levels. The last L-1 levels. That means that is 3-1 levels corresponding to the encoder returns to the original state here. When input to the encoder is zeros, when input to the convolutional encoder is two zeros. Therefore message sequence is 1001100. These are some important points. Once the structure is constructed, and encode the given message. Here vertical axis represents the A. This one is A, B, C, D. Labels are the Trellis structure has L plus K levels. L means constraint length. 3 plus K is the length of the message sequence. 8 levels numbered from 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, and so on up to 7. This one is the L is equal to 0. Next. For representation of this, we use another one. This one. L is equal to 0. Here, L is equal to 1. Here, L is equal to 2. L is equal to 2. L is equal to 2. L is equal to 3. L is equal to 4. L is equal to 5. L is equal to 6. And L is equal to 7. L is equal to 0, L is equal to 1, L is equal to 2, 3, 4, 5, 6, L is equal to 7. 7 levels are there. Initially, first L minus 1 levels corresponding to the encoder departure from the initial state. First L minus 1. L minus 1 means 3 minus 1 level, that is 2. First consider A state. Vertical axis represents the states of the convolutional encoder. Horizontal axis represents the time step. These are the step 1, step 2, 3, 4, 5, 6, 7. 7 levels are there. First L minus 1 levels. You are in state A, goes to next state A. Output is 0, 0. Goes to next state A. You are in state A. With input bit is 1. Here solid line represents input bit is 0. Dashed line represents input bit is 1. With output is 1, 1. With the help of the signal flow graphs, you have to construct this diagram. Next, at level 1, consider A and B1. Consider A and B. Again, you are in state A, goes to next state A. With 0, 0 is output, input bit is 0. State A goes to state B. With output is 1, 1. Next, B to C and here B to C and B to D. Here B to D, B to C when input bit is 0, solid line. This one is B to C. The B to C with the output is 1, 0. This one is B to D. B to D. The output is 0, 1. First L minus 1 levels. From L minus 1 levels means 3 minus 1 levels. That means L is equal to 0, L is equal to 1, L is equal to 2. The converse of the Trellis structure, these levels correspond to the encoder departure from the initial state A. From L minus 1, L minus 1 less than or equal to L less than or equal to K less than or equal to K. That means 3 minus 1, 2 less than or equal to L less than or equal to K 5. Up to L is equal to 2, 3, 4, 5. The structure is periodic in nature. The structure is in periodic in nature. By using these signal flow graphs, by using this Trellis structure, by using this flow graphs, A to A to B, B to C, B to D, C to A, C to B, D to C, and D to D, have to construct the Trellis structure. Okay. Here consider these 4 points, four states, A, B, C, D. A to A, so input bit is 0, outputs are 0, 0. A to B, transitions from current state to next state. here A to output is 1 1. Consider B state. Consider B state occurred in signal flow graph B to C and B to D. B to C. Solid line. B to C with output is 1 0 and B to D the output is 0 1. And this one is a C to A, C to this one is C to A, C to A with output is 1 1 and C to B, C to B. One is C to B, C to B with output is 0 0. Next D to C, 0 1. D to D, D to D is 1 0. The same structure is repeated to L is equal to 5. A to A, 0 0 and A to B, 1 1. Here B to C, with 1 0, B to D, 0 1, B to D is 0 1. Next C to, consider this one, C to A, C to A, the output is 1 1. C to B, the output is 0 0. Next D to C, D to C, the output is 0 1. D to D, the output is up to L is equal to 5. The structure is periodic in nature. A to A, 0 0. It is 0. Here input bit is 1 1 1. It is 1 1 like that. Next consider B to C. With B to C, output is 1 0. Next B to D, 0 1. B to D 0. Consider L is equal to 4. Consider C1, C to A. The A, C to A, C to A with output is 1 1. C to B, with output is 0 0. Next D to C with output is 0 1. D to D. The output is 1 0. Structure is periodic. Consider last L minus 1 levels. This is the first L minus 1 levels. L minus 1 means 3 minus 1 levels, that is equal to L is equal to 0, L is equal to 1, L is equal to 2. The Trellis structure is departure from the initial state, and L minus 1 less than or equal to L less than or equal to K. That means L minus 1, 2 less than or equal to L less than or equal to 5. From this 2, L is equal to 2, L is equal to 3, L is equal to 4, L is equal to 5. The Trellis structure as periodic in nature. From this one, L is equal to 2, L is equal to 3, L is equal to 4, L is equal to 5. The Trellis structure as periodic in nature covers all the states. All the states means A, B, C, D. Last L minus 1 levels. So the last L minus 1 levels. That means L minus 1, 3 minus 1. Then encoder come back to the original state. When input to the convolutional encoder is zeros. For L is equal to 6, consider M value is 0. For L is equal to 7, consider M value is equal to 0. Consider L is equal to 5. From L is equal to 5 up to L is equal to 5, the structure is periodic nature. From L5 to L6, L6 to L7, the input to the convolutional encoder is zeros. That means consider 0 points only. Here you are in state A, input bit is 0, goes to state A, with output is 0 0. Not consider 1, M is equal to 1. Here you are in state B, input bit is 0. Input bit is 0 means goes to steady state, with output is 1 0. You are in steady state, input bit is 0, goes to state A, with output is 1 1. You are in D state, input bit is 0, goes to C, with output is 0 1. The output is 0 1. At the L is equal to 6th level, only A and C are there. You are in state A, input bit is 0, goes to state A, with output is 0 0. You are in state C, input bit is 0, state C, input bit is 0, goes to state A, with output is 1 1. Come back to the original state of the convolutional encoder, that is A. Here from L5 to L6, and L6 to L7, consider M value is 0. Come back to original state of the convolutional encoder. By using this structure, Trellis structure, I have to encode the given message sequence. Given message sequence here is M is equal to 1 0 0 1 1. We use another color for green color. We use that green color here. Here M is equal to 1. Initial M is equal to 1. Solid line represents M is equal to 0. Dashed line represents M is equal to 1. That means here, starting from the A state, that means in M is equal to 1. The output is 1 1. Okay. Next. m is equal to 0. From this B state, m is equal to 0 means, here m is equal to 0 means solid line to this point. Output is 1, 0. Output is 1, 0. Here in state C, next input bit is 0. Input bit is 0 means solid line. With output is 1, 1. The output is 1, 1. You are in state A. Next input bit is 1. Input bit is 1 means goes to C state. With output is here here 1, 1 is there. Come back this one. You are in 1. 1 means dash line. 0, 1 is the output. These are the 1 dash lines. Output is 1, 1. You are in B state. Next 0. 0 state. 0 means solid line. 0 means solid line. That means 1, 0. That means 1, 0. You are in C. Next input bit is 0. C to A. Output is 1, 1. C to A. You are in 1, 1. Next input bit is 1. Input bit is 1 means dash line. With output is 1, 1. The output is 1, 1 and goes to this point here. Here you are in B state. Input bit is 1. Last one. Last one means solid lines. That is the 0, 1. B2 C, B2 T. B2C and B2T, that is B2T here is 1, 1. It is 1. Here B2C is 1, 0. This is 0, 1. 0, 1. B2 T is 0, 1. Therefore, outputs are 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. For given message sequence M, output bits are 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1. Last one is 0, 1. In this way, how to encode the given message sequence.